goes right up to a cloud, registers in real time. That was never possible.
If we have captured before all the walls are closed in, that's another piece of data that we have.
Local accuracy, that call it global local accuracy, so that it can be a sufficient solution to model small pieces.
They're connected to the cloud. They're automatically loading their data. That's a whole different level of detail.
I don't care who you are. You're not turning that around in 24 hours.
I look at it as a rising tide lifts all boats.
Good afternoon, everyone. Welcome to our webinar today. Today, we are going to be discussing scanning to simulations with our wonderful speaker today, John Niles. So, John, I'll let you introduce yourself. We'll lay out a little bit of an agenda, and then we'll get right into the action.
Oh, thank you so much, James. And I really appreciate the opportunity to come in and really talk about some of the things that are near and dear to my heart, which are digital twins, scanning, and BIM, and this culmination of everything that's come together over the last few years. It's a really exciting time in the business, and we're seeing a lot of transformation occur in a very rapid fashion. Just real quick, a little bit about me. I'm John Niles. I've been in the business for about 30 years, in and around architecture, engineering, construction, and operations. I started out as a drafter way back in the day in the Navy shipyards out in Seattle, and made my way to the East Coast now, where we do a lot of work with clients in the data center world, manufacturing, and whatnot. And just really excited about some of the things that we're doing, where we're bringing, the robotics into construction, into AR, VR, MR, and really starting to build out digital twins around all that, because it all connects together. And it's very interesting to see what the technology has done as of recent. So that's a quick agenda. I'm going to kind of just jump ahead a little bit, because some of you may know me from GAFCON Digital. Some of you may know me as an employee of Anser Advisory and Accenture. So a couple of years ago, GAFCON Digital was acquired by Anser Advisory, and then more recently, Anser Advisory was acquired by Accenture. And our group, still very autonomous, is able to operate under the Industry X within Accenture. So that just kind of gives you a little idea of where we've been at. So maybe I'll jump back to that agenda and turn it back over to you, James.
Perfect. So today, the focus, John, as you just mentioned and laid out, we'll be talking a lot about digital twins. And really excited to have you on here, your experience, and as you said, mission critical data center, kind of large jobs where that digital twin value can really, really shine. But there's a lot of facets as to what, just defining what is a digital twin, something that's hard to understand. And then how do you create a digital twin? What are the values that come from a digital twin, and how does reality capture fit into that when we talk about, even the simulations? That's what, of course, we'll be talking about a little bit today. So focus of today in a lot of ways, as we can see here in our agenda, we're going to start on the modeling. We'll be defining a little bit about, what a digital twin is. And that really starts with BIM, with a model. You have to have some sort of model to represent the digital twin itself. We'll talk about a lot of the means to get there: laser scanning, photogrammetry. That's our real reality capture solution as the best means, the best, interim solution to creating this digital twin itself. And then we'll dive into some of the asset data and some of the AI powered insights that you can do with that. AI is, it's a kind of one of the hot buzzwords today, but there's a lot of power behind it. That's why it's gained a lot of traction. And when it's used in the proper pieces, can provide huge insights. And we're talking about, huge, again, critical facilities where that information really shines. So let's, I guess, John, why don't we just start talking a little bit about BIM, building information models, the first way that really shines and ties into, the digital twins.
Yeah, I mean, absolutely. And thank you, James, for that agenda overview.
And let me say, I'm sorry, John, one last thing. We will have lots of time for questions. If anybody has questions throughout, we have a questions box. Please just put them right into the little question section. We'll answer them either as we go here through the presentation once they're typed in, or we'll have time allotted at the end for Q&A.
Yeah, absolutely. And no question is a bad question. The only bad question would be out there are the ones that aren't asked. So please feel free to ask any questions you have, and I'll try to best answer those, or I will get back to you with an answer on that. So, we talk about the digital twin, and really that starts with defining what a digital twin is. It is a digital representation of a physical asset or object or facility. We've been using BIM for a while now for coordination. You see up in that left-hand side there, we're doing some clash coordination inside of Navisworks, and that's where it's been really key for the last few years. But now we're starting to be able to infuse reality capture. Just 10 years ago, reality capture, composed of laser scanning and photogrammetry and 360 photos, those things were sort of off limits because the file sizes were just so large. Now we have the capability. There's software out there now. There's new compression methods that allow that data to be used and democratized across that life cycle. And that fills in a lot of gaps that exist within what was a limitation with BIM. Right? So typically we've had BIM models that only could be up to a certain amount. Now with reality capture, you can go beyond that with that detail. You just never physically would model all the various details inside of a system. So, in the case over on the right-hand side here, you see where some folks over at Onsite 3D, thank you, Wade, for sharing this image out to the group, and this allows you to start to simulate and bring that data, that BIM data, together with reality capture data in a way that you would never bother to model all that information. And that's where we really start to bring the value of this geometry information. We call it the visual twin because it's without the data at this point. Once we start to infuse data into this, we start to build that digital twin, and that data, and we'll get into this a little bit more in detail as we go through, is really enriched from different data sets. It could come from a data lake, it could come from IoT, could come from different sensor information. So overall, really, the BIM model has been the starting point, but in my opinion, you're going to see a change in that we're going to rely on reality capture data for our information, and that BIM will simply become part of that data set. It will just have less detail in it because you don't need all that detail, just enough to what you need to get for your owners, what they need to carry out their goals.
So John, how do you navigate, talking about, in the scale of a digital twin, you say a visual twin on one side, a full scale digital twin on the other side, and the intelligence that's embedded in that and what the owner needs. How do you navigate what the owner really needs? Because a lot of the times, when we're dealing with new technology, my experience has been sometimes they don't know exactly what they need. How do you navigate the process of really getting to the meat of what the customer needs and either assigning that as something that's more visual or more data heavy, more technical, a lot of these full scale digital twin pieces?
Yeah, no, that's a great question. Typically, the way we look at it is we got to start out with the end in mind. What are the goals and objectives of the business unit? What are the needs or challenges that are being levied on that business from outside stakeholders, for instance, shareholders? What do they want to see? Maybe sustainability, maybe carbon count, maybe just how many widgets do we have in that building? How do we maintain those? What are those capital assets that need to be monitored so we can understand what that program would look like if you've got to replace all these, say, outdated units? How are they performing? All those things can be measured, but it's really incumbent on the client to understand what it is that they want to see out of it at the end of the day. Part of our process is really to kind of sit down with the owner, understand what assets they have, what they want to track, what are their program goals, and really start to tailor that against what they have in their tech stack. So, for instance, we're very much a software agnostic company. We don't care what software they're using. However, we will work with them to integrate in the best way we can that tech stack that they may have already, or offer suggestions for how to fill in those pieces so that you can connect everything. We call it the digital thread. And that digital thread really starts with the end in mind, but beginning at design. So ideally, if you've properly aligned your data in design, then that data can easily flow from one silo to the next silo to the next silo. So in a way, we're breaking down those silos. So going from design all the way into construction, into operations, and then, future design work, and bringing it all full circle.
Okay, so yeah, I think so. I think that's perfect. And now let's say, all right, I'm in the spots like that. That sounds perfect. What you're saying is exactly what I want. Okay, and I'm an owner. I own a lot of this. What are the first steps, both technically and then maybe from a business side or an implementation process? It's like, where do I start? You're talking about something that's really big. Like, yes, I want to be able to track all this information, to document my assets, understand the condition, the maintenance of things, to see where all of this, where everything is in its life cycle, make sure I'm maximizing its efficiency, ensuring safety and that things are operating to their best. Where do I start to create something like this?
Well, I don't want to be so bold as to say, give me a call, but I definitely would suggest that. It can be a very overwhelming task to folks that are not used to doing that. And I don't say that in any sort of bad way. It's that their core business is to do something else. It may be software development, or it may be building cars or rockets, whatever that is. They have that core business. They understand that core business, and they need a little help to get up and running. And that really kind of goes into three pieces, right? One is that strategic consulting to understand what the needs are of the business, and then starting to develop those gaps, and then starting to look at the software. That's the second piece, is looking at the software, what solutions are out there, do those meet the needs, and how do we integrate all those pieces into it. The third piece of it, and this is really one of the most important pieces of it, and I think it gets overlooked, is that you need some augmentation, some staff augmentation that help get you started in that journey, right? It's sort of the crawl, walk, run approach. When you get into digital transformation, there's a lot of things that can go wrong with it if it's not implemented right. And we've all probably been on a project like that at some point. I've been on projects where take software A and implement it, and it's a success. Software A is then used on another program or with another client, and it's not implemented the right way, and that whole outcome is a terrible experience, and they say they would never use it again. So those are the opportunities to get it right from the get-go, are important, and very lasting to the business. If you've got that sour taste in your mouth about an implementation, then you're not likely to go back to it. And so I think that that's been somewhat of a hurdle within our industry. As we said here, we have this ability to build digital twins, and then we just turn it on and let folks try and figure it out. That's probably the worst approach that we can take.
Sure. So let's jump to kind of more in your shoes and in the reality capture space a bit. So, you've outlined well what a lot of the big factors are for someone who's an owner who wants to start investigating, questioning this, and now jumping into the feet of a user and people who want to implement it, and also not ignoring one of the owner major concerns, which is cost and ROI. Ultimately, how do the technical tools and what are your first processes look like moving from that? After the initial questions, here's what you want, here are the important needs, now let's actually start making the work happen. You've got clear communication between yourself and the owner on what the expectation is, on what they want in their final deliverable. What does it look like, boots on the ground, to start making the digital twin happen?
Yeah, no, that's a great question. One is bringing the source data in to the system, and usually that's through some sort of common data environment. So a good example of a common data environment is something like Autodesk BIM 360 or AConnect or a whole host of different systems out there, depending on the needs. There are reality capture common data environments. We talk about, Preview 3D, Cin2, Verum. A lot of these different systems out there allow you to bring in that disparate data and start to look at it. Where we take it to a digital twin is when we start to be able to infuse that asset data back in. So a very easy example to think about is Tandem, which is an Autodesk product. That allows you to bring that asset data and that visualization in there. Depending on the client's needs, we may look at something that's more bespoke, using Azure digital twins, for instance, or AWS, bringing those systems in with those large amounts of data. And depending on what the client's needs are, some clients don't want to be on a particular platform. So those are the things that we kind of have to navigate through once we get that data collected. And then the other piece of it is really starting to build out what we call program management, which is really looking at, how we, govern over that, putting standards in place to make sure that the data is the right format. It's as simple as that in some cases. In other cases, there's legal contracts that get put in place. Thou shalt deliver the data this way, or this is important to us. And depending on what the use cases are, we highly encourage owners to develop use cases that they want to see in that data set, right? So we can build digital twins that track every single thing, but you're going to get buried in data very quickly because, for instance, how long do you want to store that data? How long is it useful for? Is it even germane to the business, right? Just because we say we can collect the data doesn't mean that we should collect the data. What makes the most sense to the business? And that may evolve over time as well. So, and we're seeing technologies where, say lighting, for instance, now we're seeing power over Ethernet lighting, but they're also including all these other different sensors inside that fixture. Those can all be tied back to a digital twin. Now, it may be arguable about what kind of information should be surfaced, how much that information should be surfaced, for how long should we keep it, and when do we discard it. So there's a lot of rules that kind of go into place with developing that out.
I think that's great. When you're putting all these rules in place, what sort of does the customer have to have a pretty reasonable infrastructure already to track and to isolate? I guess help identify what rules are necessary. How much of that do you take on yourself? What are the first? And I guess my question rising from here, when you're implementing the digital twin, is it something that's implemented kind of an all-in-one? Is it a heavy lift up front, in terms of your data acquisition, like you said, collecting all the information, creating the asks, and then implementing something that's relatively static? Or is it something that is really dynamic at the end result? And do the final data metrics on whatever you're tracking and whatever you've given results on, or giving some sort of information on in the digital twin, how adaptable is that in the entire life cycle of the digital twin? And coming back, last piece tying into is the data collection and the initial introduction. Will you or could you shoot yourself in the foot by assuming the end result is a little simpler than it is? Like, how much of the process and information up front and either legal talk or detail of answers is important to get that end result? You talked about tracking electricity over things like Ethernet. If you start with a relatively simple ask to create a digital twin, and then the ask develops either in the same piece of time or later on a few years down the road, is that something that can be added and implemented? And at what cost do those sort of asks become maybe inhibitive to the entire project? Or at least at what time do you usually cut out smaller details like electrical for Ethernet and focus on some of the other maybe bigger pieces, power for obviously something like a data center? That's like an obvious kind of checking, like how much power is being consumed at each space.
Yeah.
Where do you draw that line, or how do you navigate even getting to that spot?
Well, we're going to work very closely with the owner to understand what their needs are. I mean, that drives a lot of it, and that does evolve over time, right? So we can build a digital twin and we can start to add to that over time. Now, you may not have that data historically back before you created that new data set, but you can certainly connect that in. It's fairly straightforward to do that. It's just a matter of identifying the needs, identifying the outputs that you want to see. What's the, say the, if we take a mechanical, for example, as an example, right? What's the high temperature? What's the low temperature? What are those set points? What do those look like? What kind of air differentials do we have? What are those set points that you need to see? Same thing with electrical. What are the things that you want to track, right? Do you want to track the efficiency of something down to the rack, or do you want to only go down to, say, the distribution network, right? The PDUs. So a lot of that really is driven by what the client's looking for and some of the best practices that are out there. Sometimes we don't need to track down that far. Maybe it's just down to the PDU, not the rack, because someone else owns that rack. So there are things like that we can look at.
Got it. Okay, great. Well, I think we should continue kind of within this line. You have your laser scanning piece up. How do you use reality capture, laser scanning, photogrammetry, in creating this digital twin? And there have been a few questions asked so far that I think will be really great. We'll hit those here.
Yeah, if we want to go through some of those questions, we can do that too. Sure. Laser scanning is fundamental. I believe it is the foundation for which the building is built off of. Laser scanning has its limitations. It's obviously a line of sight sort of tool. So you have to scan multiple places to get that total picture. But once you do that, you get a pretty darn accurate picture of what's going on. And you see here, we've got some green here and some red. And what we've done is we've done a comparison BIM model to existing conditions. And you can see where there's differences that exist. For instance, there's some conduit that's modeled there that really isn't even there in the actual scan. Why is that? Well, maybe it was removed. We don't know. Either way, it's outdated, and it brings a question. Another example is the roof hatch or the skylight that's up there. It's in the wrong place. That's kind of big deal when you're going through and starting to build a new design and say you're running conduit through there. You don't want to put conduit underneath the skylight or a hatch. I mean, that's going to be a problem. So I like to think that laser scanning is the all-encompassing truth teller. It's going to tell you the truth no matter what. There are best practices, obviously, around making sure that you've scanned correctly, making sure that you have control set up and geospatial, coordinates and whatnot, so that everything lines up the right way. But it's really powerful, and there's like tools out there now that allow you to have that common data environment for laser scanning, so you can share it with the rest of the stakeholders. And that, I think, is probably the biggest transformation that's happened in, I would say, the last 5 years, is that we've went from collecting this data, putting it into an application like AutoCAD or Revit or something else, or maybe even Navisworks, and looking at it from a single user or maybe just a small group of users. Now we have the ability to take this point cloud, this visual twin, and democratize it. So we can put it on, a platform that's on the net that allows you to access it very easily. You can slice and dice the pieces that you need to bring into your design, or you can just take measurements off of it. We're seeing a lot of value with contractors being able to just go into the model and start to run their dimensions on it to understand, hey, what's going on in here, and they're doing their due diligence. They don't necessarily have to go out to the site to physically walk it. Obviously, they likely will, but if they are in a pinch, or you've got an estimator back at the office, or working from home, they can use this data now. They can make those accurate measurements. The other thing is that we can slice and dice floor plans out of it very rapidly. We can do sections out of it. These are the things that are just incredibly powerful for that foundation, making that foundation, plumb and square, so that the rest of the building, the BIM, can sit on top of it, is fundamental, right? We can check to make sure those record models that are coming back in BIM are matching up with what's existing out in the field. More importantly, we can use laser scanning to start to build a time capsule, so to speak, of the construction process. That's incredibly valuable when it comes to starting to understand what's under the floor, what's out in the parking lot, where were those pipes routed in the wall? Are they over here or over there? That then turns into a visual twin for operations, because now they can go back in that time capsule sort of fashion and say, hey, this is what's behind the walls. If you want to put a doorway there, you really don't want to put it there because there's a big, huge conduit line running through there, right? We don't have to tear the wall out to find out. We can simply go back and look at that scan data. So inherently, I think that brings value to the price of an asset. Wouldn't a building be worth more money because it has that digital record along with it? It's much like the maintenance on an airplane. There's value inherent to that, right? If you know that the records have been kept on it, and you know what kind of maintenance was done on it, you understand a little bit more about that airplane. So, conversely, put that back into a building. That building should be more valuable, should it not? I ask that question. It's something to give thought to. And I think that we've not looked at it in that way before. So I think that is, that's another opportunity there. So that's why I'm very bullish on laser scanning as being part of that solution to that digital twin. It's the foundation.
Yeah, I think that's fantastic. The one of the big pieces, I think, you're correct in saying that there's obviously more value knowing what's behind the wall. I think your airplane analogy is great. The maintenance, especially when you're dealing with, really large, high efficiency, expensive facilities, understanding how it was maintained, having records of all of that, having that be a digital twin. And then in these areas that are often under frequent development and maintenance, what's behind it? What is the maybe the cost or the process, or even other means, laser scanning? We had one question asked, which we'll come into a little detail more, but on the technical pieces and scanners, one thing that is somewhat inhibitive for people using reality capture is that it gets to be either, and the question I think phrased it well, cost prohibitive or intrusive, to go out and to scan, to bring a terrestrial laser scanner on site every time to capture what's behind the walls, especially at every stage of a job. Like, that's not easy or simple information to capture, and that cost can add up. Are there other methods for creating digital twins that you can use? And what does cost look like? Or if we don't want to get into the line by line, what does it cost look like? What are cheap solutions people can use that are still effective in creating a digital twin and don't create this huge issue of, whoa, you're gonna terrestrial scan every piece? That's a lot. That's a big deal.
Absolutely. And one of the most inexpensive ways to get into capturing a site is through photogrammetry. So I've got a couple of examples here. One was a drone flight over a site during utility burial. And as those utilities were being put in, the client wanted to fly the site to understand where those data points were going, or where that infrastructure was going in. They were building multi-building campus, and they were going to have to tie into this stuff later. So they wanted to see how that would go together. By taking the BIM model and overlaying that into the drone imagery, we could see where that data was being laid. They also started to use that for their pay apps. So how much piping had actually been installed, and then they could take the BIM model and do some rough calculations off that and understand exactly how that occurred. Another example here you have with the 360 camera mounted to a hard hat and walking the site. This was using a technology called OpenSpace. And you see that you can quickly walk through the site. It's very simple to set up. There's a number of vendors out there that provide this service, but it allows you to quickly acquire data. We're talking $300 camera, and the software automatically uploads to the cloud. It's a very easy way, very inexpensive way to start collecting data. And this data, while it may not be something that you would necessarily, pull dimensions off of, for example, and they're working on that, is that you have an understanding of what was put in behind the walls. And maybe that's just good enough, right? I can understand how it was constructed, what was put in there. Was there something missing? We can easily do that, and you could start to bring in that BIM data. So again, just really inexpensive ways to collect that data. The one on the right hand side there is a software called Luma AI, and it allows you just to take a video. And in this case, this is Nikola Tesla's statue in Niagara Falls, the father of electricity in my viewpoint. And we were able to capture this in about 20 seconds. You can turn that into a Gaussian splat or a NERF model very quickly, and pull that into different systems to use that. So another inexpensive way to get into capturing. So it doesn't necessarily have to be a $60,000 scanner. It can be something much easier. Now, does it have the same details as a $60,000 scanner? No, it doesn't. And so really selecting the device for the right output is important, right? So, again, there's a lot of inexpensive ways to get into this. Photogrammetry is probably one of the easiest and least expensive ways to get into the game, and that may suffice for your needs. So hopefully that answered the question.
Yeah, I think so. I think so. And I think that begs, several bigger questions too, because talking about a whole range of technology, when you compare, photogrammetry and a lot of these photo solutions to, your higher grade terrestrial scanners, it all comes down, like you said, to the use case. What are we going to use this for? What do we need to actually capture, and how detailed do we need that information to be? So looking at identifying, we've got a major conduit line behind this wall. That's a bad place to put a door, like you said before. You don't have to see and know everything, but if you want to, use that for, as something that you're going to give to an engineer to branch off of for things. If you want to route, you got to replace things, you have to tie into existing systems. That requires a little bit more detail most of the time. An engineer's going to need to know the specs of what he's working with, and to see just a photo, maybe that's sufficient, with getting some information sometimes, but very often, terrestrial scanners have their place. So there's a whole nother, I think, a whole nother room for conversation to happen on deciding what technology fits into the best space, and then even blending those technologies together. How do we use a mixture, like you said, of 360 cameras with something like terrestrial scanners, and then of course implementing things like survey control, and you can talk about adding drones into that as well, which obviously has its overlap, but there's to get that whole informational piece. And similarly on the digital side, you said figure out the customer's needs, break it down by kind of engineering your own technical plan to encompass the right technologies in the right places to maximize efficiency and also minimize costs. That's not an easy thing to do.
Yeah. Well, one of the things that and I saw that there was a question about, can you create a point cloud with 360 video? That's exactly what I did with the Luma AI. There's other systems out there like Sitescape that I think is part of Faro now, and their WebSphere product that allow you to bring those types of data sets in to the overall point cloud. So you can take that terrestrial data, or you can take that LiDAR data or mobile scanning data and data from your phone basically, and pull all that into the same area to look at it and aggregate that whole entire data set, so you can create a mosaic, so to speak, of the entire project. And it really just depends on your needs. If you just need to capture a comm closet or electrical closet with some stuff in there, so you can bring it into Revit and model that out, then that may fit the bill. That may get you 95% there, just using a mobile scanner. If you got something that's got a lot more detail in it and it's got a lot more coordination, you're obviously going to want to go with something heavier duty, obviously. But also, you also have some different tools at your disposal once you start to go to some of those bigger systems. And that's in increased density, increased accuracy, and then also the ability to add peripherals to it to do other things. So, for instance, if you've got some high bay things that you've got to be able to put a tripod on and crank it way up in the air so that you can get that line of sight from a different vantage point, so that you can stitch all that together. Again, it really comes back to the need.
Okay, well, fantastic. Well, I think we've got just a little bit more content, maybe on some of the asset management piece, and then even tying in AI, and then we can jump into a few questions here. And if you can here, John, we had a question asked a little bit detailed in terms of asset data and management. We had one question asking about industry niche digital twin platforms. Can you speak at all to some of the more specifics, trade-offs, why one might be better than the others? Maybe from an asset side, you can branch that, of course, into other areas as well. But things like Bentley iTwin, Tandem Forge, and other, not just that, but then scalable platforms, AWS, Microsoft, Siemens, what kind of platforms people should consider for their digital twin solutions?
I'm going to say keep the aperture wide open. Now there are specific clients that have needs to say, we are adverse to using this ecosystem because we're already on this one. And so we will gravitate towards that to help them out with that process and understand what that tech stack may look like. But also, how much transformation do you have to do with the data to get it from one system to the other? A lot of the time that will sort of start to dictate costs associated to that. If there's a high risk of we're going to have to do a whole lot of API integrations and writing code and getting all that stuff to move from one silo to the other, then that may not be the most advantageous pursuit. There's no from our standpoint, we won't use any of those things. Those are all excellent systems that were mentioned. It's just a matter of what that fit is to that end objective, right? We'll take any data and pull it into that BIM model if we need to, but we've got to condition it in such a way that allows it to travel into that data with the least amount of friction, right? So
what are some of the factors? I'm sorry.
Oh, no, go ahead.
Why might it swing one way or another? It's like you can work with all of them. They're all great solutions. Is one a little more industry specific than another? Where are some of the strengths, at least on a high level?
Each of them has their strengths and each of them has their own weaknesses. I don't want to go into the strengths and weaknesses as much as, look at what your needs are and understand what those needs are and what those end objectives are, and then how do you get to normalizing that data to a certain point that you can ingest it into the systems. I mean, there's just, to say there's one system better than the other, it would be crazy, because in 6 months, it's all going to change. I will tell you that the change that we're seeing just around digital twins, I think for a while there, we were in the trough of disillusionment with digital twins. I think NVIDIA has reinvigorated that discussion. Some of the things that they showed off during their keynote a few months back were really interesting, and we're already working with some of those partners in that space. And so it's very interesting to see just how that's all coming together. But it's a rapid transformation that's occurring, and a lot of it has to do with how we're enabling it on the back end in these data centers to crunch some really big data. I mean, this isn't some small task, and I think that's probably was a little ahead of its time, and so we kind of had to regroup, and we're coming back with it now. I take the analogy of a digital twin. If you've ever been inside a Tesla or any new car, you've got a digital twin there on your dashboard, right? You push the brakes and the little light comes on the dash of your digital twin of your car. That's pretty easy to replicate because you're building the code for specific parts from a specific supplier that's going to give you those inputs back. When we talk about, the built environment, every building is a little bit different. Even if you were to take the blueprints of that building and duplicate it on another campus somewhere, that equipment may be different because of supply chain issues, or hey, this new model has come out and we've changed it. So all those things kind of add up into being a snowflake, so to speak, for buildings. And that's where it gets a little challenging. So just trying to best fit, all those different needs, all those different types of equipment, and getting them all to talk together can be a pretty daunting task if you haven't formatted the data the right way. And so that's part of that process to making that all work. So I know I'm not answering the question, which is the best digital twin out there. There's a lot of them. And
Well, lump one more question on a similar kind of thing in with this, and that's what in defining these characteristics, what are the characteristics that are most important in a digital twin platform as a service? For example, flexibility, integrations, visualization, niche to AEC, pricing model, etc. What characteristics, when someone's saying, okay, what should I look at now that we know there are all these, they all act a little different. What are the factors that you should think about to start weighing and deciding what the best platform will be?
No, that's a great question. I think visualization is huge. I mean, let's face it, BMS systems have had some sort of digital twin for a long time, but it was very flat, static. It was a schematic, and it would be green or it would be red. And I'm oversimplifying that, but that in essence was a very simple twin. But the visuals weren't there. Now we have the ability to have the visuals there, and that allows us to surface much more complicated items. For instance, we did this work on an old Navy ship and building a digital twin from that, taking that what was a scan, converting that to BIM models, and then pulling that into a digital twin by being able to surface that data, and marrying those things together gave us that digital twin we wanted to see. Now, in this case, the visuals were much more important than, say, the data was, so to speak, because they just wanted to be able to query, hey, what kind of equipment is this? Or if there's an anomaly with it, where's the valve to go turn that off? Or how do we shut the power off to it? Those are all things that, need to be kind of thought through at that end process. What do you want to see? Maybe it's just for maintenance. We want to be able to surface some of the data. When was the last time that filter was changed, or was that valve exercised? Those types of things can be then input into the system. Hopefully that answers the question a little bit.
All right, perfect. Well, not to take away then from the, I guess, where you intended to go with assets. Do you want to continue talking a little bit about asset data and the importance of that in digital twin?
Well, that's a critical piece. That's where we go from a visual twin to a digital twin. That's just as fundamental as that. It's all about the asset data. And that asset data could be static data, could be, PDFs, it could be specs, it could be, warranty information, anything like that, all the way out to IoT sensors. They're giving you continuous feedback on how a system is operating. It could be data that's locked up in there that gives you information about carbon, or how that building performance, or that those measures that you would use in building performance simulations. Those are things that we would look at. So you kind of go full spectrum. And again, this is why we talk about understanding what the needs are for the client and their business, because that really informs how you're going to start about going out and building digital twins, because that's the data you're going to want to have to collect at the end of the day. I know we were going to talk a little bit about AI insights. And I'm really excited about some of the things that we're starting to see in the industry around reality capture and BIM and AI to start to make sense of some of this crazy reality capture data that didn't make a lot of sense. There's a lot of folks out there now like Sin2 and Preview 3D and Avere, which is now a hexagon product. I think it's now Building Solutions, where they're able to start to use AI to begin to really make sense of what's going on in that point cloud, right? We can start to tie asset data to that. That's very interesting because now we're basically bypassing BIM as that medium for that information to be contained within. So I'm very bullish on what's happening in that space. We can start to use that data we could start to do analysis on it. So, for instance, down the bottom side there with building solutions, it's a tool that allows you to see what's been installed, what hasn't been installed, if it's deviated, and in this case, you see that yellow duct is in the wrong place, and then we can start to put that to a project schedule. How's that performing against the other trades? Why are we behind in this trade and ahead in this other trade? Why are we deviating? And when we talk about building in mission critical spaces, there's a lot of thought that goes into why piping and conduit and cable trays are put in a certain hallway a certain way, and that's to allow for future expansion. And in some cases, we'll see a trade goes out there and they're the first ones in, so they put their stuff wherever they want to. This allows you to be able to course correct that very early on, and mitigate that issue right from the get-go. It also gives the superintendent an extra set of eyes to be able to see what's occurring without necessarily having to be and catch every single little thing. And we're in a resource challenged environment now, so these tools can really help those resources, those folks that are out in the field, gain some additional insight. I'm going to start to use this for our OAC meetings, right? Where you're meeting with the owner, the architect, and contractor to understand how the progress is occurring on the project. Lots of really great insights, and it's all based on using AI to start to look at those different systems. And I'm just starting to scratch the surface with this. I'm really excited about what's happening in this area and where we're going to be at in a couple of years.
Yeah. Well, I think that's a good transition, because we had another question that hit closely on some of the pieces you just mentioned. And I even want to add a little bit of a question to it. I'll do that right afterwards. But the question here, can you speak more to where the industry is at regarding creating classified mesh products and how that might be used to more easily parse together dissimilar models or technologies to further enhance the digital twin deliverable? And who is doing that work?
Yeah, that's a really exciting place to be at, and I think AI is really helping drive that forward. I'm really excited about what's happening in that area, and it really started with self-driving cars, I think, in my opinion, and now it's sort of bleeding over into this into the AEC industry, and I think. We're starting to see, companies like EarthCam that can actually do segmentation of humans walking around. Do they have a hard hat on? That's where he started at. Can they wear gloves? Now we've detected that there's a fire in a dumpster. We can automatically call the fire department. I mean, those are the types of insights that we're starting to get out of being able to take that data and break it down into those basic components. Being able to understand, hey, this is the shape of a pump. Are we at the point where it's like I can tell you that this pump was made by this manufacturer? Probably not, but we're getting pretty close. And we can start to tie that data to that pump so we can give it some intelligence. That's what I'm really excited about. I think over the next couple of years, you're going to see that piece of it really take off. That auto classification and segmentation of data is going to be transformative, yet as the next wave, so to speak. Great
awesome.
question.
And one piece that, we have a few more questions here, and then I have a couple questions for you that are still coming up as well. But let's stick in the AI bit. So if AI is applied to recap data, decreasing on the owner's dependency on BIM data, does that decrease the pressure on AE and designers to contribute to digital twin content?
Absolutely not. I don't think so. And I think it only augments. We need the design team involved. We need BIM models. There is a place for them. Absolutely. What we want to be able to do is be able to take that BIM model at the end of the day, and rather than shipping it over as a drawing set, which is the legal binding document, right? We want to be able to see that model, but we also want to update that model so it's a record model, so that all those changes that happen in the field are reflected in that model, so that they have a model that now can be used for operations. It's really just taking that one step further. There's a lot of hard work and a lot of decisions that are made, and a lot of thought goes into those design models, and they're absolutely incredibly important for the whole entire process to work. One of the things that we like to do is work with the design teams to actually start to infuse that data earlier on in the process, normalizing that data so that if you've got a serial builder, for instance, they're using that same data set, those same families with that data structure already embedded in it, so that it can be carried through and into operations. So we're just adding data to it. It's a great question. And yes, they're very much, there's not going to be a replacement of BIM anytime soon. I would say that the importance may change, and it will be part of that overall picture that we develop out.
One question that I have coming into this too, when we're talking about digital twins and its use cases, we've had a couple pieces that really focus on the construction side and somewhat of a coordination and development side, and then some of it applying to facility management side, the data and the information there. And the two are not entirely separate, because it's the owner who obviously incurs the cost for the digital twin, at the end of the day for both. But the purposes of the two are a little different, are they not? Can you talk to does the digital twin being served for maybe construction differ in effort, work, especially in the asset or AI powered data information side from what you might want on a facility management side? Is it one and the same process? And how do you manage that working with, say, the contractors building this from a technical informational side, and then end delivery of the owner?
Oh, that's a great question. So, obviously, the first thing that we like to start with is with the design team, putting in those key pieces of information, the normalization of that data, so that when it goes into construction, it can be used thoughtfully in a way that it allows that data to coexist, right? We look at it as almost like, layers being turned on, right? And that additional data is useful in construction because they need to fabricate off those. That's where they build their spooling drawings. That's where all that awesomeness happens. And that's how it all shows up on an 18-wheeler on site and gets bolted into place the right way the first time. But that data it has to make it back into those design models as a record model. And once that record model is built, and if it's built correctly, it's already well formatted, it can flow into operations. So they're separate processes and they're separate endpoints for them. But at the end of the day, if you develop those record models the right way, then a lot of that data can move from construction back into operations.
With using it in the construction phase of things, how critical is it to use it in the construction portion relative to just the facility maintenance side, relative to changes? You mentioned, first guy to show up on site, he might just put the stuff where he wants. You're catching it because you're using scanning, photogrammetry, and then using that as a means of updating, so you have an accurate digital twin. If you're not using this in the construction side, does it make a digital twin at the end of the day even worthwhile? Or if you're not maintaining it, how much maintenance goes into that, so that as you continue to work, improve your facility, changes happen, additions are made, how much work goes into maintaining that digital twin so it stays useful and it doesn't become an outdated drawing like everyone already has on their facilities.
I've worked with clients that, I've simply stated they just want, a drawing printed out at the end of the day from their BIM models. Very short-sighted, not seeing that future. And then there's cases where let's get it right. Let's make sure that that data gets back into the system the right way so that you're creating those record models. At the end of the day, I kind of use the analogy of what I learned as a VDC BIM manager, in that you only can clash and resolve clashes in models that are participating in the clash coordination. I cannot clash against a non-existent model because it doesn't exist, right? In cases where you have structural steel, but there's no provision for supplemental steel to be modeled, you have a real problem, because that supplemental steel is going to be in the way of certain things that are going to be in that building as far as finishes and mechanical and electrical. But absent of that, you're not going to get a clash because it's not there, right? And so that data that doesn't exist, that it's got to be made up, or it's always going to be missing, right? That's why I'm very excited about what reality capture can bring, because if it's done at the right time and the right intervals, you can make up for that, so to speak, in a way, and capture those details that aren't going to be otherwise captured. I mean, if you don't model it, you can't visualize it, right, at the end of the day. So it's really important that those other trades are participating. Hopefully
Awesome.
that answered the question.
Yeah, I think so. I mean, I think it did in a lot of ways. Like you're saying, it's it came back to what you started with in so many ways of what's the purpose of the digital twin. You want its documentation and information, living, breathing, visual, but more than visual, on something that's there. And if that something that's there isn't where you think it is, or new things are being added, or they aren't, in the right place, at a certain point, it becomes so different, so variant from your original, what you have, what you're working with, if it's a model, that it diminishes value slowly with each deviation that's made. So all of those start to add up and start to stack up. So it's really got to be something that almost begins its maintenance and checking. Or not almost, it entirely does before it's even built. That's a part of building the facility itself, making sure it's built according to plan, updating through, you said, coordination. Yeah. So you have a fully as-built model, with the ability to get all the asset and metadata there. Tracking that through the way is pretty integral to making sure your final deliverable is. Yeah, one
of the things to remember is you're spending a whole lot of money designing and constructing a building, and you're spending a lot of that money up front for the first, 18 to 36 months that the building's being constructed and commissioned and put in use. And that's going to be there for 40 years. So why would you let that data go dormant? Why would you let it go sleepy? Why would it become useless? And it will become useless if you don't use that data right from the get-go. Because the further time goes on, the further changes occur, and those aren't documented and put back into the system, the chances are that it's going to fall out of sync, and you'll have a huge effort to basically put that all back together. The other piece that I wanted to hit on was around just how this data can be used at a much bigger level. So when you think of owners that have, 10 buildings or 500 or, in some cases, 2,000 buildings, how do you take all that data and surface it up and understand which building is at the most risk? I mean, that's where the power of digital twin starts to come in, and where you start to look at smart cities. You're looking at really these big, huge amounts of data and trying to make sense of it, and those drive a lot of costs to upkeep these campuses. And is it worth maybe it's time to tear this building down? Maybe it's lived its life, or maybe it needs to be renovated, or maybe it just needs a little bit of this and that. Those sorts of insights can be serviced by using digital twins across a campus or even a whole portfolio.
I think that's great. Well, we come down to, I think, our last question right now. We touched on this before, and we can get maybe a little more specific on it. The question is, the time and effort associated with field data collection from terrestrial scanners can be a bit cost prohibitive and intrusive. The question, I keep getting told it's still the most accurate. Has other tech out there caught up in the accuracy and ability to build a Revit model with something like the Navis VLX3? Are there other scanners out there, cheaper and less intrusive methods of data capture will make this happen faster? So that gets a little specific. Maybe you can answer some of that, John. I've got a couple thoughts. I'll chime in as well.
Yeah, absolutely. I mean, I think the speed to getting your data back out to the right people is huge, right? Now, you may sacrifice that speed by saying, hey, I'm going to limit my accuracy. But we are seeing so many changes in the industry around devices that are capturing much faster. Enabled with cloud compute, they can start to make sense of all this data. So, for instance, when I started out in this, it would take you would spend a day out in the field collecting and spend another 2 days post-processing. By the time I got the data ready and served back out, they'd already poured the floor, for instance. All right. That's not useful. That's just a waste. But now we have the ability to go out with very similar scanners that are enhanced, that are connected to the cloud. They're automatically uploading their data and making sense of it, and can have it turned back around in a matter of hours instead of days. It's taking the manual process out of it. We're looking at, you're starting to see robotics be employed that can go out and scan in the middle of the night and upload their data, and it's ready to go in the morning to make actionable intelligence off of it. That time crunch is continuing to collapse. As far as intrusiveness, I can't speak to the intrusiveness. I know that nobody likes, someone coming into their office and scanning, because they may have a dirty desk or something like that. But, hey, we used to have to do that anyway. We just used pen and paper and a measuring stick, and we'd have to do the same thing. So I think in some ways that's less intrusive, because you're coming in and you're scanning, you're done. You could come in and do it in the middle of the night and be done. So yeah, I think you're only going to see the continuation of the automation, that AI starting to put things together much faster.
Mm-hmm. Yeah, I think that's absolutely a valid point. I think that's one of the most exciting things in this industry is how the hardware in computers has increased and improved so much that it allows new workflows. And when we're looking at the technology and trying to find what's the best scanner? Are there cheaper, less intrusive scanners to capture this? What is this comes down to, I think, a couple, like you said, John, a few critical questions that help you find what the best instrument is, what's the best scanner for this job. And the turnaround speeds, as you were mentioning, are have unleashed new capacities to get something that, like you said, maybe just goes right up to a cloud, registers in real time. That was never possible. But to get that and to get information on site, that's huge. That's game changing. But that's not always the case. Sometimes getting real time information might be the most important thing. I need to know if stuff is poured right now because concrete's going down, and if I need to move sleeves, I need to do it now before concrete goes there. I need to see where my PT cable is before it gets poured. Perfect. Great. But sometimes that's not the case. Reality capture technology for, as-builts, creating an as-built when there's no existing documentation might say, perfect, I need that technology placed. Not just in the turnaround speed. Yes, I want turnaround speed, but I'm more concerned in accuracy. I need to create a model of structural steel. I need to model in Revit all of my conduit, on this, huge space, which may be a data center. It's like, okay, that is not something, I don't care who you are, you're not turning that around in 24 hours. You're not turning that around on site for somebody, it's a whole different process. And
yeah, you're absolutely right. You shouldn't. And it's a completely different use case. And that's why I always talk about start with the end in mind, because what do you want to get out of it? If you're just trying to capture a closet, with some electrical equipment in it or some communications equipment in it, you probably could do that with a phone, right? Or some photogrammetry. But if you're looking to go in and understand what's going on in my refinery, for instance, and I need to put in a new piece of equipment without ever turning all the rest of the equipment off, I've got to snake this thing through that. That's a whole different level of detail. It goes back to your analogy around conduits. It's selecting the right devices for the right application and understanding that there are time differences in that. Now, when we talk about building digital twins for this, I like to have more data than not more data, right? And so if we have captured before all the walls are closed in, that's another piece of data that we have forever. If we save it the right way and we manage it properly, we've got that forever. And that's useful into operations. And someday, with the power of AI, we're going to start to make sense of some of these other data sets that we have not been previously able to. So just saying, well, it's not useful is probably the wrong approach. There's going to be a time where it's going to come, and it will be.
Yep, absolutely. So to I guess close out this last question with two things, and this is this hits on a few things that we at Reality Capture Network are doing. One of them, of course, is our event. Many people here probably know we have our annual conference. The conference would be a great place to kind of see these technologies. I can't speak to what specific vendors right now are doing that, but the mobile technology, SLAM solutions are improving. I know their major goals are, preventing drift, increasing local accuracy, call it global local accuracy, so that it can be a sufficient solution to model small pieces. That's what everyone's chasing. The technology improvements from groups, like you said, NVIDIA, people who are making these hardwares are allowing more processing to go into the software that, on the front end and the back end, both from the modeling software side and the registration side, the data collection pieces are improving. So there's lots of pieces all getting better and better. And there are so many SLAM providers out there that are doing their thing. So I would encourage, anyone looking into answering this question, come to our event, meet, shake hands with the providers, see their workflow, because that's one of the big pieces, see how they perform, in different areas, what their turnarounds, what they look like incorporating, say, with survey data, terrestrial scanners, what their accuracy is like. Best way to do that is to meet and shake hands with people. Another thing that we are doing is we have these committees that we've launched focusing on finding the best technologies and practices for different industries and on different types of, industries, projects, but then also defining the best kind of technologies in this. So when do technologies need to be tied together? When you're looking at some type of industry like an industrial site, what technologies do you want to put into them? And we have one working now. John, you're a great part of that laser scanning committee. We have a laser scanning committee aimed at defining the best technologies, practices for blending technologies, what's necessary, what some of the star players out are in those. And I'd encourage anyone listening who wants to dive deeper into those topics, participate in the committees, come work with other professionals. We've got over 100 people who have been involved so far. So I'd encourage you to come and collaborate with other people on that topic.
I couldn't have said it any better than you just did, James. And, I really am excited about what we're doing with the RCN network as an advisor and also a contributor to that, seeing that change occur in the industry. I look at it as a rising tide lifts all boats. That's what the essence of that whole program is doing. And it's also starting to educate folks that are getting into this business. This business is only going to continue to grow, and there's so many opportunities within this to learn from. And I'm very excited about the RCN conference in Boise. It's going to be fantastic. This will be my third year at it. It is one of the best conferences that I go to all year, where we can touch base on all the things that are happening in reality capture. It's absolutely incredible, and you'll have access to some really incredible folks during that conference. So,
yep, and I'm part of Reality Capture Network myself now, of course, but this will be my fourth year at the conference. And it's just gotten better and better each year. My background was scan to BIM, working from the vendor side, and I learned so much, connected with so many great professionals. So obviously this is, a little self-plug here perhaps, but didn't always used to be. I am a huge fan of the conference and the committees. Just a question here we answered, where can you find the committees and how to participate in them? I just sent a link. So if you can see all of the answers, I believe everyone can. So there's a link you can follow. Otherwise, the best place to get there would be go to the Reality Capture Network website, and then you can navigate to our community page and under committees. So again, realitycapturenetwork.com. At the top, you'll see the community page, and then we have our committees underneath. That's where you can apply, get involved in the committees. Right now, we have laser scanning going. There are lots of committees that we are opening and diving into. One of them, digital twins. So everything we discussed, if you're passionate about this, how to navigate, and dissect some of these questions a little deeper, because, over the course of this hour, we can only go so deep. So we want to really dive into what's the best program for specific industries. That's something you want to talk about, apply, come collaborate with other people like John, working in digital twins, working on a lot of these jobs. Yeah. So I suppose with that, I think we've answered all of the questions.
Yeah, if there's any other questions, I'm happy to entertain those, and please just reach out to either James or myself, and let's keep the discussion going. And I hope to see you at the RCN conference in October.
Thank you, John.
Yep.
Thank you, John. Thank you, everyone.